All right, welcome back. This is our last lesson of the year, and I'm excited. Summer is coming. It's great. The last lesson is about a center of data. Okay, so we're gonna be talking about a little bit of statistics, I guess. Kind of very basic, like basic statistics. We are going to be looking at mean and median today. Okay, so I guess the first question is, well, what are they used for? Okay, so mean and median, if you haven't heard them before, median might not. Okay, but mean you might have already heard that phrase or that word before. Mean. Okay, so mean is basically used to describe the center, the average, of data. Okay, actually, not just mean and median, both are talking about what they're used to describe what a typical value is in the set of data. Okay, so what a typical value is, what the center of all these values are. Okay, so for example, if I collect everyone's height in our class, mean would be like the average of the height. Median would be like what? Okay, so mean and median, actually both of them would be like, well, what's a typical height of this class, right? So you won't be the highest or the shortest, right? You won't be the tallest or the shortest. You'll be like somewhere in the middle. Okay, so it's used to describe what the middle is. Okay, I guess that's another one you can say. Okay, it's used to describe what the middle is, typical value. Okay, so mean and median, they are using a different method to describe what a typical value is. Okay, so first of all, mean. Mean is calculated as below here. Mean is the numerical average, and then basically to calculate for mean, all we need to do is add up all the data and divide it by the number of data points that we have. Okay, so here's the first example. It says Mr. H loves to play Rubik's Cube. He bought 5 of them at different prices: $2, $10, $20, $15, and $100. What is the average cost? So when you're looking for the average cost, okay, or the average, that means we're looking for the mean. Okay, and to find that, the average cost or the mean, I'm gonna use mean here, doesn't matter. Mean is going to be, okay, so it says add up all the data. So here we have $2, we have $10, 20, 15, and then $100 Rubik's Cube. And then we have 5 cubes in total, so we divide it by 5. Okay, so that's how many cubes we have in this scenario. And now you just add them up and then divide it by 5. Okay, so I'm going to put this into a calculator. You should get 130 plus 17, 147. Let me just double check. 30, 17, 47. Yes, divided by 5. So that will give us 29.4. So that would be the average cost. The average cost would be 29.4. So $29.40. Okay, 29.4. So that's what the mean is, or that's what the average cost is for each Rubik's Cube. Okay, now, okay, so that's the average cost. Okay, we'll come back to this answer in a second. Okay, here's the example number 2. It says Mr. H also loves to play board games. He bought 6 board games for his birthday at different prices. And these are the prices: 30, 40, 35, 36, 30, and 31. What is the average cost? So again, we're looking for the average cost. That means we're looking for the mean. And to do that, we add up all the prices here and divide it by the number of board games that he bought, which is 6. Okay, so then put this into a calculator. Okay, so let's see, that's 70 plus 35 plus 36 is 71, and then 38 plus 31 is 69. So add those 3 numbers, 210, and divided by 6, this is $35. Okay, so this is the average cost for each board game, $35. So that's how you calculate the mean. Okay, it's not, hopefully not too difficult for you to do. Basically, again, to find the mean is that you add up all the data and then divide it by the number of data points. Okay, so that's mean. Median is actually the middle number. Okay, it is the middle number when the data is ordered numerically. Okay, so you order them from the smallest to the biggest, and the one that appear right in the middle is the median. Okay, so for example, in the first example here, what is the median? Well, if you list them, all these prices in order from the cheapest to the most expensive, so $2, $10, $15, 20, and 100. Okay, so the one that is right in the middle, so if you just cross one out from the back, in the front, one from the back, one from the front, one from the back, this is the last one remaining, so that is what the median is. Okay, median is the one that is right in the middle, like right in the middle, right? So it's called median. So that you could say that's a typical value. Okay, maybe not. Okay, we'll see. So, but you can see this is the median. So again, this is used to describe what a typical value is. This is mean, and that is $29.40. That is also used to describe what a typical value is. They are actually quite different. Okay, think about which one is probably a better representation of the center. Okay, actually it will be asked here, so we'll come back to it in a second. Okay, let's finish the calculation for the median for second example. So same thing, what we need to do is to list out the numbers in order. So we start with 30, and then what's the next one? 31, and then 35, 36, 38, and 40. Okay, so again, we cross one out from in the front and back, front, back. Okay, now you can see we have two left. We can't simply cross both out, then otherwise we're left with nothing. So in this case, when we have even number of data points, what we do is we cross out the ones from the back and front until we have two left in the middle. And what we do, you can take a guess, is we're going to take the average of those two. Okay, we're going to find the mean of those two numbers. So the average between 35 and 36 is going to be $35.5. Okay, so that is the median for the second example. Okay, so again, when you have even number of data points, you can see there's 1, 2, 3, 4, 5, 6. There are 6 of them, and therefore there won't be a one middle number in the list. So what you do is you take the average of the middle two. If you have like odd number of data points like this, 1, 2, 3, 4, 5, then you are guaranteed to get a middle number, and well, that middle number will be the median. Okay, so here's the question: which one is a better representation of the center? And to answer this question, we can actually look at our examples. Okay, so for first example, you can see the mean and the median is actually quite different. However, in the second example, here's the mean and here's the median. They are actually pretty much the same. Okay, they're pretty similar. So I guess we can look at the first example and then think about which one is a better representation. Okay, so for example number 1, which one do you think is a better representation? Okay, hopefully you thought about it. Personally, and I think most of you will probably agree, the better representation for the center in this case to describe what a typical value is would be median. Okay, you can see here the median is 15, and you can see all these prices: $2, $10, $15, $20, and $100. So 15 is like, makes sense. I mean, outside of this $100, very expensive cube, the rest are actually quite close to 15. I mean, $2 is kind of off as well, but 15 is, kind of typical. I mean, 3 out of these 5 are close to 15. Whereas $29.40, none of them is really close to $29.40, right? The closest one is $20, but it's not even that close either, right? And then you can see $100 is way off. I mean, $100 is way off in both cases. And the $100 case is what we call an extreme value. Okay, it's the outlier, what we call the outlier. It's just out there, on their own. It's just so far away from the rest of the data. Okay, so it's called an outlier. But you can see this average, the mean value, is actually affected by this $100 by a lot, right? Because of that $100, it brings up the average cost. Whereas if you look for median, the $100 here actually doesn't do much because we are actually not counting that one, right? That one is just a placement. It's the last most expensive one. But when we look for the median, we just eliminate those, right? We eliminate the very cheap ones, the cheapest ones, and the expensive ones. Okay, so we just eliminate them. Really, we don't really count them at all. But it does play in a role if we calculate for the mean. Okay, so in this case, example 1, I would say median is a better representation. It is a better representation, and again, because of the I mean, it is closer to most of the data points, so it is definitely a better representation. So median is good to use because it's not affected by the extreme values. Okay, so very big or very small, they don't really affect what the middle is. Okay, whereas mean, if you have a couple of $100 Rubik's Cube and the rest at like $10 each, it's gonna drive up the average cost by a lot. Okay, so the extreme values actually play in a huge role in calculating for mean. Okay, so but median doesn't. So in first case, I think median is a better representation. Example 2, it doesn't really matter, okay, because you can see they're both quite close. And usually if that's the case, then we just use mean. Okay, I mean, there's nothing wrong with median, but in that case we probably just use the mean, okay, the average. Okay, so they are both good representations. They are both good representation of what a typical cost is. Okay, so that's the difference between mean and median. Okay, mean is the average. Median is the actual middle number when you list them in a numerical order. Okay, now let's look at example number 3 and see how we can use the idea of mean to calculate some questions, I guess, solve some problems. It says, after marking the test, Mr. H calculated the mean score for pre-calculus 12 class to be 85%. And it's a pretty good test. However, he woke up the next morning, realized his cat ate part of the test, of one test, and the mark disappeared. Okay, and he cannot remember what this student got. But he still has other tests, and these tests have the scores of 80%, 86%, 76, 90, 95, 100, and 100. Can you help Mr. H to calculate what the missing score is for this test paper, for this poor student? Okay, so the average, okay, the mean score is 85%. And there are, does it say how many tests there are? There are, oh, it actually doesn't say, but what he has 1, 2, 3, 4, 5, 6, 7 test scores. One test was missing, right? The test score for one test was missing. So in total, there are 8 tests. Okay, there are 8 tests in total. 8 tests in total. Now it says the mean score is 85%. So then if you go back to this formula right here, mean, that is equal to the, so if you add up all the data, this is the total, right? So it's the total divided by number of data. Okay, you can write it like that as well. So mean is 85. We can actually use that formula, so I'm going to write it down here. Mean is equal to total divided by number of, in this case, number of tests. So we have the mean of 85%. We don't know what the total is. I'm just going to call x. Okay, we don't know what the total is. we do know there are 8 tests, right? So we can actually figure out what the total score is. Okay, you know what? I'm just gonna write total. Okay, so hopefully you remember how to solve this equation here. To solve for total, remember that's total divided by A. So to undo division of A, you gotta multiply by 8 here, multiply by 8 here. So 85 times 8, I believe, is 680. So the total score is equal to 680 marks, I suppose, okay? 680. Now, here are 7 of the scores. So we can actually figure out how many marks there are out for these 7 people, and then we can figure out what the last score is, right? So the total score, total known score, would be simply 80 plus 86 plus 76 plus 90, 95 plus 100 plus 100. And if you actually add them up, you can see actually all these scores are pretty good. So you could imagine the last score is probably not very good. Okay, but anyways, let's take a look. It's 180 plus 186 plus 76 plus 185. Okay, so if you put this into calculator, you actually get 627. So the total known score is 627, and we know that the total score will be 680. So the missing score will be 680 minus 627, which is this student actually scored not $53, what am I talking about? 53% on this test. Okay, so that's what you can do to solve this problem. Again, you can find the total percentage, I guess, in total. There's 680%, but we know the total known score is 627%, so whatever that's missing would be the last person's score. Okay, all right, so that's the average. That's part A. Part B, I guess, what is the median score for this test? So to find the median, then again, we list them out in order. So that's 53, and then we have 80, before 80 there's 76, and then 80, and then 86, 90, 95, and then 2 100s. Okay, so the median, again, you just cross out one from the front, one in the back, keep going like this. You end up with these 2 in the middle. So in that case, you find the average. Okay, so the median is going to be 86 plus 90 divided by 2, which is 88%. Okay, so the question is mean or median better to describe the center in this case? Okay, so the average, the mean is 85 and the median is 88. To be honest, I think they are quite close. But if you were to ask me which one is a better representation, I would probably say, oh, it's pretty close. I would say probably 88. You know what? I don't think there's a better one here. They're both quite close. They are both quite good. Okay. If I really have to choose one, I would say median is better by just a little bit. Okay, I would say median is a little bit better. Not by much, okay? Because I mean 85 and 88, they are pretty close. Okay, I probably should give you a better example when you can see the difference. Okay, and the reason why I think median is better is because it's I mean, you can see these, which is the majority of the data, is actually, you know, closer to 88. Well, 85, I mean 85, 86 is quite close. So again, I don't think there's a good answer here. It's just based on a personal opinion. I think, because they're both quite good. So really, in this case, you could say mean is better, and because you actually take everyone's score into consideration, so you can use that as the argument, and that's totally fine. You could also say median because that's kind of where most scores are closer to. But again, in this case, I think either of them or both of them are actually quite good. Out of these three examples, really, it's the first example that does have a big difference. Okay, that one clearly median is better. Example 2 and example 3, I think median or mean, they are both just fine. Okay, there's nothing wrong with either of those. However, for first example, median is clearly a better representation. Okay, so that's it for today. Hopefully you'll see the homework down here, assignment. You just need to find the mean and the median, and then tell me which one is better, okay? All right, good luck everyone. And this is our last lesson, so thank you for watching. Cheers.